Alright, I got everything all soldered up. It actually worked up pretty nicely. Got my circuit board already chopped up, and I'll probably cover this with something to protect it. But I already have my adjustable resistors pre-tuned to what the car actually needs to like flash at a decent rate and whatnot. So I give a little demo here. This is with just taillight or brake power. Or sorry, turn signal and brake power. And this is with taillight power. So I'm actually pretty happy with it. And the way that it's going to go into the housing, I have the housing here that I explained how I cut apart. The half ring and the full ring will pretty much mount exactly where they did before. I'll probably drill these out with a small drill bit and put a screw in to hold them more securely. And same thing with the full ring once I slide in there. But my circuit board will actually sort of rest down in here because there's a tab that has to mount here, but I should be able to like Velcro it or something in here so it doesn't rattle around and get all messed up. But that's the next step, is getting it in here. So real quick, I'll explain the circuit and how it works. So I explained how I actually took control of the half ring, and this here is actually how I control it. You can see I have up top here, I have the brake from the circuit board, the turn signal from the circuit board, and the taillight from the circuit board, and then just various ground connections across. The way that I actually control the half ring, you can see I have a little control pin here and a regulator pin here. That's from the IC chip as the control, and then back to the resistors on the half ring. That's the regulator, as I would call it. But the way I have this set up, whenever the control gets power, there's a transistor here. The control power runs to the collector of the transistor, and I take a resistor and connect it to that power and run it to the base, so that way whenever there's power to the control, it actually allows itself through, because the transistor just acts as a switch. But that was just the best way to be able to allow it to control itself and also take over that control. So you can see I have a stack of other resistors here, but first I'll explain the delay circuit here. The delay circuit consists of a capacitor, a 555 IC chip, and a resistor, an adjustable resistor. And pretty much whatever power is applied to it, based on the capacitor and the setting of the adjustable resistor, the IC chip delays and eventually puts power out through pin 3. So I utilize that along with this control, and basically whenever you have either taillight or turn signal or brake power, there's two things that I have happen here. First, power comes through, and there's two diodes here that prevents the brake from backfeeding into the turn signal and prevents the turn signal from backfeeding into the brake. But whenever either of these get power, it energizes the delay circuit, and the delay starts taking its time to output to pin 3. So while that's happening, down here, the control pin, initially it gets power and allows itself to go through to the regulator, but once the brake power is applied, there's another transistor here, and I have the base of the control transistor connected to the collector of this one. And whenever the brake or turn signal is applied, it goes down through a resistor that's connected to the base of that other transistor, and it basically steals the control power away from the control. So it basically overrides the control and makes it so the half ring won't light. But once the delay circuit is finished and it outputs to pin 3, this other transistor is basically in the same stack up, and it robs the power from the brake or turn signal transistor, and it actually allows the control to go through. So it's actually pretty simple how it works. And this lower stuff down here, this is actually to compensate for the taillight power being on. So whenever they're dimmer, when you have your headlights on, that was actually a complication I ran into. And the way I overcome this, I take power from the control, run it to the collector of a transistor, and when you apply brake or turn signal power to that transistor, it gets through this one, but it also has to go through a secondary one, and this one is controlled by... Okay, my camera died on me, so I didn't get to explain the taillight portion of the circuit. If it wasn't for the taillights having to light a dimmer brightness, I wouldn't actually need this lower part of the circuit. But after explaining everything that happens up here, with everything that goes on, this the delay and these transistors make it so that the control is not applied whenever or while this thing is still waiting for the delay. And that's an issue whenever you have the taillights on. When you have the taillights on, they have to be at a dimmer brightness. And the way that I compensate for that, I make the brake or turn signal power go to a transistor that takes the control power, and with power through the brake or turn applied to the base of this transistor, it allows the control to come through to here, and it gets held up by the second transistor. The second transistor is controlled by the taillight power. So whenever you turn on your taillights and hit the brake or turn signal, for just the time of the delay, it'll allow the control to go through, and at the very end I have a resistor set to like 60k or something like that, and this makes it so that the full brightness that should be applied when your brake or turn signal is on is actually dimmer until the delay allows the full amount of the control power to come through. So it's for those of you that don't understand circuits, it's really not super complicated. These are sort of like a bunch of like relays in a row, and I just tell them what to do when they need to do it.